Today we're going to be talking about removing friction from MLOps processes. It's obviously the most exciting thing to start your Friday morning with. So I threw a few memes in there. I think I'm maybe too old to do memes properly, but I threw them in there just to make it a little bit more interesting. So let's get started. So in terms of data science and AI, machine learning, every organization at the moment is trying to scale out with AI. And you can see the benefits that they're receiving. So looking at 30% or more efficiency gains, increasing revenues 5 to 10%. It's not a big surprise, and I think that's really just scratching the surface. We're seeing lots of breakthroughs daily, as you, I'm sure, are aware with ChatGPT. I get to be the first person to say that during this conference. I'm sure it's going to come up a lot more. But people are scaling out, looking to do more models faster, more things with the models, really pushing that envelope of what they can actually do in their organization. And you can see this across pretty much every single industry, from banking to pharmaceutical, manufacturing, retail, everywhere. But what we're seeing is that organizations are struggling to scale. So after the initial models, they've had some success. They're great, let's start investing, let's start making more and more and more models. And you'll find that, as you can see here, again, 1 in 10 data scientists' work end up actually going to something useful. The rest is maintenance, it's looking for data, it's trying to get something actually productive out of their day. Only about 11% of POCs, proofs of concept, are actually getting through into a production state. I'd say that's probably high from what I've seen, so there must be someone that's dragging up the average here. But quite often people will spend weeks, months, years building something out only to find out that by the time they're ready to productionize it, they haven't thought how they're going to productionize it, they haven't worked out exactly what they're trying to do, what the business value of it is, or the landscape has changed so much that by the time they get through it, something else has come along, something new and interesting. Either that or the data has changed significantly. Worldwide pandemic happens. They have to start switching to something completely different as well. So, analytics process. What is it? I'm sure most of you are pretty familiar with it. Obviously, this is an ideal process. So starting with business understanding. What are we trying to solve for? What is the actual issue? What's our target? How do we see value? Moving into data understanding. A lot of time should be spent here. What data do we actually have to solve the problem? Do we have the right data, the right quality? Do we have access to the data? How are we going to distribute it? Data preparation. Again, this is very iterative, so understanding how to make the best features. What is a good hypothesis that we're going to use for our data science model? Solution building. So this can be anything. It could be building out a model. It could be building out a project, analytics. It could just be building out a dashboard. All sorts of different things. Moving into the evaluation phase, understanding how well is that solving our problem. Are we actually solving the problem? And then that feeds back into that data understanding. Do we have the right data? How do we deploy it? All of the rest of that. But we find that obviously it's rarely linear, and I'm sure all of you have experienced this before in your lives. So to start off with, business understanding. Did they get it right? It happens that people will say, okay, this is our business problem. Problem is, we want to stop fraud. You get to the data understanding, hand it over to the data science team, and they say, okay, that's great, but what do you mean by stop fraud? Do you mean stop all fraud? It's an easy way to do that. Just flag every transaction. Done. Achieved our business objective there. Is it maybe we want to stop high value frauds? Okay, we can do that as well. Reduce false positives so that our customers stay happy and they're not getting flagged every transaction that they try to do. Maybe we want to balance this out. So there's lots of different things that you have to go back and really understand what is the root of the problem, how do we see value out of this? Likewise, getting into data understanding. I mean, so many times in projects I've gone through and thought we had the right data, and then have a look at it, dig down, and you say, what does this field mean? This F12649, and then they say, oh, well, that's whether or not we investigated the fraud. Okay. So our model that we use based on that, that gave us incredible results, is probably not valid. Maybe we need to go back and check this again. Likewise with data preparation, understanding exactly how to change this data and what is a sensible approach to doing this. And then, of course, solution building. Like, data science is a science. It's not just apply a formula. It is something where you come up with a hypothesis. You say, okay, I think that the best way to capture fraud is by looking at transactions that occur in quick succession, or that start off with an initial charge which might be low value, so someone tests it out by trying to pay for gas. And then they go to Best Buy and try to get something that they can move very quickly or resell, which was typical. It's changed now, but that was a typical MO. So you would start to use these type of transactions and really understand what fraudsters were going to do, and then build models around that using the data preparation side of things. So again, it's going to be very iterative, going back and forth between those. Evaluation, obviously we talked about, and then deployment, like how do we want to consume this? Is this going to be something that we run once a day? Is it going to be something that we have an API for that we can query? Do we want to build a web app and interact with that? What type of integration are we going to need throughout the entire thing? So again, lots and lots of different things that can go wrong or that need to be iterated over the top of. And this gets more and more complicated when you start to realize the number of people that are involved in it. So business understanding, you might start with a subject matter expert, someone that knows the business side of things. You might have a data scientist that is not a subject matter expert at all, but knows data science extremely well. You might have a data analyst that sits in the middle of the two of them and tries to do translation of requirements. So starting to bring in more and more people here. Then you have the data team, data custodians, security. Who is going to get access to this? Are we going to have PII data? Where is this data going to reside? Can we even use this data in our model? Is it legal? How quickly do we have to delete the data? So all of these teams start to come into play. Are we the architecture team? What type of architecture are we going to build upon this? Do we have approval for using these tools? Data engineering team, if you've got a separate team from data science that might want to make sure that data pipelines are up to date and delivering the data at the right time with the right quality, that we're monitoring all of that as well. So again, more and more teams. And then the deployment side of things. So going from development to production is a massive hurdle. And quite often you're going to find out that what you have in production in terms of like infrastructure and data is completely different to what you have in development, which obviously causes a ton of different problems because a model is only good as the data that you build it on. If you're building a model in development and then moving it into production and the data is completely different, it's not going to be a good model. Likewise, if you're building something out on a certain platform with certain tools in development and trying to deploy into production where the infrastructure is completely different, different version of Linux, different version of Python, you're going to have different results, different errors that might come up, different stability issues. So all these things to kind of think about as well as you're going through. And what we're seeing is that quite often each of these groups is running very siloed. So the subject matter expert team, they do have an interpreter essentially for the data science team. It's not like they're talking to each other. And if they do, the data science team might take the project, run with it for a couple of months, and then go back, have to explain what they did to the business team. The business team says, I don't understand this model. Make me understand this model. Data scientists don't really love doing that. They say, look at the documentation. And then business team says, I don't understand your documentation. So another challenge is trying to get people to communicate in the same way together. So all of these challenges come up, and we start to see all of this friction appearing. So between building and deploying, we've got the data engineering team trying to make sure that they give the right data at the right time. Got the subject matter experts trying to quantify or qualify content with expectations, trying to translate this into something that makes sense for a data scientist. You've got the IT team. Are the models performant? Do they stay performant? Is everything secure? Are we exposing APIs and data that we shouldn't? What restrictions do we have to put on in terms of data retention, PII data, and things like that? Risk management, very big one here. Is the model safe? Is it compliant? Are we going to get audited on this? Do we have to explain what we've done? IT ops, how easy can we deploy it? There was a time when everything got recoded into a different language, which was painful. You would have a backlog of projects waiting to get pushed to production while someone had to understand exactly what the model was doing, recode it from Python to C or something similar to that, work with a legacy tool, and try to make it all work out. And then how do we monitor it ongoing? Anytime we have model, anytime there's a data drift, there's model drift, there's prediction drift, there's all sorts of different ways that this model can change and become less valid. And obviously, is there going to be bias in there? Again, are we predicting the right things for the right people? Are we being biased against certain people? Is that changing day to day? And does it still fit our requirements? So are we still trying to achieve what we were trying to achieve originally? And so you see this breakdown of this entire life cycle here. Things start to fall apart pretty quickly, particularly once you start to scale out. So you've got 10 models. Sure, manual processes might work, making sure everybody kind of gets together and communicates at some level in an ad hoc fashion might work. But once you get to 100,000 models where you start to see that real gain across the organization, particularly for large organizations, small organizations, maybe you might be okay. But what we'll see is that as the number of models go up, you're going to see the cost going up if you don't have a proper MLOps process, if you see these frictions in your MLOps process. And then AI ML becomes a cost center. It starts costing you money. You're not getting the benefit out of every model incrementally that you put in. You're actually seeing more cost. Inefficiencies, opportunities, additional risk being one of the worst ones. Here's my first meme. I think I did all right. I always relate to this dog. So many things in my life. Okay. So what should we be targeting for MLOps? So MLOps is designed to be a set of practices. It's not a set of tools, it's a set of practices that aims to standardize and streamline. The main goal here is to make it repeatable, to make it easy, to remove those frictions. Ensure that our quality stays high, but also focused on our outcomes. So MLOps is based a little bit on DevOps, for those of you in software. Very similar kind of continuous improvement, continuous deployment, ensuring that production and development are essentially mirrors of each other, having gateways between the two of them. There's an emphasis on things like automation here as well. So really taking that pressure off things, off the manual users, and reuse and things like that as well. So just really understanding how we can improve this process remove those frictions. It's also very related to things like governance and responsible AI. So the operations side of things is about making sure that we have consistent performance, consistent uptime, enabling that entire life cycle to happen as smoothly and as easily as possible. Responsible AI obviously has a bit more around bias, making sure you're using the right data, making sure that you're predicting the right things. You can explain what you're doing, and that kind of comes back into the MLOps side of things too, because you need explainability. You need to understand what your models are predicting, what data you're using, why you're predicting it, outcomes, things like that as well. And then AI governance is going to have the same type of things in there as well. So AI governance is more on the, I guess, the controlling what gets pushed and when and by who. So it adds that extra layer over the top of things. So we don't want everybody just pushing models into production. We want it to be validated. We want it to be reviewed. We need to make sure that models are maintained, that drift is not occurring, as we said. And so in terms of MLOps types, there's a few different types. And actually having multiple deployment processes is not a bad thing. So we talked about standardization, but standardization can mean a number of things. And so you can have like a range where the data science team, for example, is a bit more autonomous. They can manage deployments. And if we're looking at things like regular updates, we're looking at incremental changes to an existing project, it make a lot of sense to have the data science team run with that. For large risk, large scale, very slow upgrades, maybe it makes more sense to have IT manage it. Or maybe there's a balance in between. So there's a few different ways that we can go about this. So, keys to success. Standardization and control. We kind of talked about that already. So making sure that when we build something in dev, we push it into prod, we know it's going to work because they're pretty much the same. Now, data restrictions aside, as close as you can make it is obviously going to be a better thing. Likewise, versioning of all of the environment, the architecture and things like that makes more sense as well. That controlled movement into production. So governance is obviously already required in many industries as well. But it's becoming more of a thing. So you'll see that audit, use of AI, use of ML is going to be really controlled and made sure that everybody understands what you're doing. Last thing you want to do is push something into prod, not knowing why it's predicting what it's predicting. So that explainable AI comes in there as well. And then the monitoring. So as much as possible, we want to have a central location to be able to monitor these projects or models, seeing what the drift is, seeing how often they're being used, what they're being used for, things like that as well. Simplify and automate. So data scientists, like, no one wants to spend their life just looking at your existing projects that you built already and making sure that they're performing. It's the last thing you want to do. When ChatGPT comes along, you're like, I want to play with that thing. It's cool. I don't want to check for drift. So as much as possible, let's see what we can take off that. Let's see if we can move to increase automation, notifications, make sure that all of that drift is being captured, making sure that we don't have to spend time going back and iterating over these things. Can we automate retraining of models when they start to drift? Can I get alerted? How often do I need to monitor my models? Like, we don't know. Like, it really depends on how much the data is changing, how much consumer use is changing, end user use is changing. So let's automate that. Let's make it frequent. Doesn't make it, like if we run something every month, every week, and it's automated, it's not going to be a big load on my shoulders. Maybe infrastructure might have a complaint about it, but regardless, it's not going to make a difference. Obviously, working with governance as well here to simplify and automate. So we don't want to just automate moves to production and things like that as well. It's the last thing we want to do. Having a human in the loop is always a good thing, in my opinion, just to validate it. And the simplification of a tech stack, it makes a big difference. Like if everybody's using something slightly different, it makes it very difficult to mirror up those environments. So where possible, simplify. If it's not possible, then work with it. But everybody has their pet tools, and sometimes it's very hard to get people off of SAS or COBOL or whatever they're comfortable with. Trusted and collaborative. So everybody needs to trust these models. We need to understand what they're doing, and that includes the end users. So a fair number of my clients have come to us and said, listen, we built these really good models. Our business users won't use them. They don't understand why. Might be targeting customers, and they're like, they already know how to target customers. My model's telling them to target a different customer. They want to know why. Like, where's the benefit for them? They've been doing this for 10 years. It's worked for them. They've hit their targets. Why do we need to change? So we need to be able to communicate that to them as well. And as we saw at the beginning, like people working in silos, if everyone's working in a silo and not communicating, then we're going to spend more time iterating over things. And obviously, the further you get into a project, the harder it is to go back and restart it. Like if you got the business problem wrong from the beginning and you get to deployment and then someone says, well, this is not what we wanted, that's a lot of wasted time. So being agile, being able to communicate throughout, preferably having something that allows everybody to work in a collaborative fashion is going to help. So, short pitch, being a vendor here, obviously, you guys were expecting it? No? Okay. Dataiku is a centralized platform that is aimed around this. Obviously, it's just one solution for MLOps, but we do have those capabilities end to end. So visual code recipes, model versioning, visual workflows, automation, things like that as well. Actionable metrics, checks, ability to push to production, ability to version control throughout as well. Now, I mean, usually I would give a demo, but you can come and see me at the front if you'd love to see a demo of this. I'm more than happy to talk about MLOps all day, every day. I'm not sure that everybody's the same, but this is what it would look like, essentially. So again, one way of solving for MLOps problems. Give everybody a platform they can work on. Visual, easy to use, collaborative, extensible, integrates well with other platforms, other tools, allows people to code, drag and drop, visualize, explain. You can do the same thing with a lot of different tools. Piece them together. Look at the cloud offerings. Go to AWS, they've got maybe 100 different offerings on there. And you can make a really nice MLOps platform. It takes a bit of getting used to, a bit of work, but you'll get there. Dataiku, obviously, has it out of the box. Again, more than happy to show this at a demo at the front if you want to talk about it further. And so we've moved from this situation where everybody's working in silos, where there's frictions, where there's misunderstandings, there's concerns, and we've moved to something that's a bit more team-friendly, where everyone can work together. And that's what we want to achieve with this MLOps process. So really understanding who is doing what, where, when, why, what are we delivering on, how well is that performing, all of the rest of it. And that would be the end. So